Hi, exam 2 review with a lot of enthusiasm, right? Like, can we just figure out something else other than exams? Like, everyone hates them, students and professors and everyone involved, and we still have them. Why? Can we just figure out something else, right? Anyway, the dreaded exam 2, which you guys scheduled for um, on Canvas, and you scheduled it for 12, 4, 5, 6. There we go, Friday, Saturday, Sunday. Take it at any point in life. 90 minutes, about 10 problems. Why do I say about? Because, I can't write. There we go. I say about because it could be 8, could be 7, could be 9, could be 10. And the reason is that some of these problems are just long, take forever. Eigenvalues, right? They have to find eigenvalues, then you have to find one eigenvector, then the other eigenvector, then to write the solution, right? And then you have to do that twice at least, right? Then there are repeated ones, that there are complex ones, and so on. So we'll see. All take time. Should I even mention undetermined coefficients or undetermined coefficients in the mechanical or electrical setting, right? We talked about all of those, and it's just forever to get those calculations done. And then we have all of those conversions, right? Using converting into the systems or converting from the systems back. It's just calculation after calculation, calculation. It takes long time. Like, this is definitely the exam where you do not want to rely on, oh, I'll just gonna go find similar example and solve it, because you're gonna spend time to find similar example and what's relevant, and then by the time you study it, you will have no time to write it out. It's not the time to try and beat the system. You really need to learn this stuff, especially that you will be using it later. I mean, it's another thing. So, what do we have in this as topics, right? So, exam 2 on chapters 3, 4, and 5, the stuff we obviously covered in class. There's more in chapters that, we skipped over some concepts that are either not in the syllabus, or they are because of the format of the class, we didn't get to them. But we did vast majority of everything, so technically make sure you just check all of the lectures we had, and make sure that you have all of the parts covered and studied. So literally everything that I talked in class is fine. And before you jump and say, but hold on, you're not supposed to have 3.1 in it because we already had midterm on it. No, you're losing that argument instantly, because when I am talking about undetermined coefficients, for instance, the first half of the solution for undetermined coefficients is going to be your 3.1 or 3.3. So there's no way to avoid that. Also, when you are back in chapter 4, right, 4.2, trying to solve those systems of equations by substitution and converting them into constant coefficients, well, yeah, you just converted the problem into 3.1. So technically, the entire chapter 3 is on the floor, because necessarily parts of your problems that are tested in the later chapter 3 and chapter 4 are all 3.1 and 3.3 in the anyway. So chapter 3, we did 3.1 through 3.7. chapter 4, we did 4.1 and 4.2. We didn't do numerics. We did the numerics in chapter 2, so that was good. Chapter 5, we did 5.1 through 5.5. We were supposed to do 5.6 as well, but we had to, rush a little bit, so we might go back to 5.6 at the end of the course. Take a look at it. So these are the exact sections, and again, don't make the argument about 3.1 through 3.4. We had that before and so on, because it's just used everywhere in here, and that's, just gonna go without it. So what are the topics? So we have the large topic, right? The constant coefficient characteristic equation. So constant coefficients differential equation. And then you have the homogeneous part and the non-homogeneous part, which will introduce undetermined coefficients, right? So constant coefficient differential equation, which is equal to 0, which is using characteristic equation. And then you have application in mechanics. And then you finally have your undetermined coefficients. And then you have your variational parameters. And then you have mechanical application again for this, because it introduces resonance and all that kind of stuff. Oh, plus electrical. Right. And then we're moving into chapter 4 with the first order systems. And those, right, we have either substitution or elimination. But I'm going to write here in blood, know how to convert, and then I'll just say differential equation into system, and system into differential equation. And I have to put this in red because for whatever reason, right, students frequently skip over that concept of conversion, and then they look at the problem, they say, we have never seen this before. Well, you have seen it, you just didn't convert it to get it into the form that you are used to. So solving the second order constant coefficients can be turned into a system, and then system can be solved through, let's say, eigenvalues. Or, right, you can have a system that you use substitution, and then you turn it into a single differential equation, into a differential equation of the second or third order or whatever, and then you solve it using characteristic equation in 3.1 and 3.3 and whatever. So these conversions go both ways, and depending on which conversion you use, you will either be using chapter 3 or chapter 5 to solve it, but both conversions are in chapter 4. And that's why it's important to kind of put all of these concepts together. And now on chapter 7, we have, chapter 5, bullet point 7, we have matrix review, I guess. And this is where you can do the matrix multiplication, inverse, determinant. Right? That's all linear algebra. It was all in 5.1. And setting us up for important stuff. Eigenvalues plus eigenvectors. And those have 3 flavors, right? Distinct, eigenvalues, complex, eigenvalues, and repeated eigenvalues. And those are multiple chapters, right, from your. Then you have that gallery of solutions. Those are the pretty pictures that we had. And then you have, again, mechanical / electrical application. No, just mechanical. Done. That's the exam. Now, clearly, I can't put all of this on it because this exam would be like 10 hours. So a word problem in mechanical is going to address, 2 or 3 bullet points. And then, because a single mechanical application process which has undetermined coefficients inside, right, is taking care of 1, 2, and 3 instantly. And then a separate problem, let's say variation of parameters. Problem number 5 could also address the stuff up there. First order system of, let's say, substitution. Could be elimination as well, doesn't matter, right? So substitution or elimination from 6. And then matrix multiplication, maybe an inverse or something, from 7. And then you go into the problems that also take like undetermined coefficients forever, which are eigenvalues, right? Eigenvalues, either real or complex or repeated, right? Depending on what you have. The gallery of solutions is usually a multiple choice question, maybe 2 multiple choice questions with pictures that if you have Mac, right, you can open and answer. And I told you put the Google Chrome browser on it so you can see them. I mentioned that a couple of times, so make sure. I mean, it's differential equations. No one should be using Macs, obviously, but maybe we have, someone. It's usually, right? DifEq sitting in that math class, you already know that you shouldn't be using that garbage. But I don't know, maybe we have someone. And then mechanical applications, like I wrote mechanical application that's word problems. I wrote that 3 times because we do learn it in 4 or 5 different sections, plus all of those extra problems and things they have at the end, mechanical vibrations and so on. It's a very, very frequent topic, and it's much easier to use than electrical one. So it's everywhere is mechanical, and maybe electrical, right? But you don't have electrical in each one of them. Electrical is far worse, obviously, in terms of calculations. But again, it's not impossible. So these are the topics. And you definitely have to pay attention to eigenvalues and eigenvectors, because that problem could be like 15 points. So long and painful. Now it's not going to be, large with like 3 eigenvalues, and then you have to, waste an hour. That's probably going to be something, 2 by 2 short to show that you know the way through it. And it's just because, again, we don't have infinite amount of time. I mean, I could make the exam 2 hours long and then, have 10, 11, whatever problems. But then, guys, come on, in 2 weeks, in less than 2 weeks, you have your final going. Like, no, actually, just over 2 weeks, but less than 3 weeks. You have your final, which will be a 2-hour exam. So there is no reason to go crazy. And I think that's it. I mean, I think we covered we have all of the topics, and it's on Canvas, we have the date, we have the time. You still have the 5 minutes to email. I forgot to mention that. I have to mention it again, 5 minutes to email. And email work. Now that work is for your partial credit and all of that stuff. We don't have any graphing on this, so it's not like if you don't care about partial credit, you want me just to mark what's right, what's wrong, then don't bother sending email, obviously. But if you want me to look into your partial credit, then yeah, send it. Yeah, I think that's it. Yeah. So hopefully you will prepare, and don't forget, it's sometimes this weekend whenever you have time. Bye.